Good morning, everyone, and welcome to Safety's webinar. Today, in this webinar, I would like to discuss with you and to introduce you to the RSAccess solution. With RSAccess, we can revolutionize the traditional role of DMZ. My name is Ronen Koenig, and I'm VP Marketing and Product at Safety. So let's start the webinar. First, I would like to go over with you and do a quick overview of the role of the DMZ networks and how it all began. So in the beginning, before the DMZ networks were existing, all the applications were hosted in the LAN. The firewall had to open ports in order to allow access for users to have access to the applications that are in the LAN. So any user request would have to go into the internal network of the organization. This is, in this way, the external employees or guests or any ad hoc user would have access to the internal network. This was also a very interesting situation for hackers, because hackers utilized and took advantage of this situation, and they attacked the firewall and did over a port scan. And they also managed to penetrate into the internal network of the organization to have access to sensitive data and even sometimes to compromise the entire LAN. So then the DMZ was created, and the role of the DMZ was to limit external access to the internal network. So external facing applications were moved to the DMZ, and external users can only have access to the DMZ. So with the creation of the DMZ, external users don't have any more access to the internal network. So the DMZ started to contain static web pages and static information. And only the external users were able to access it, and they didn't have to access the internal network. Today, more and more applications are actually being migrated into the DMZ. And the DMZ now contains all the external facing applications, and it's becoming a very, very big network to maintain, and creates a lot of operational complexity on the organization. What we find in DMZ networks today, we find a large volume of sensitive data that now resides in the DMZ. There are many ports open in the firewall to allow each one of the applications in the DMZ to access the internal network and get up-to-date information. We find a hardware and application licenses duplication between the internal network and the ones at the DMZ. Network design are becoming extremely more complicated, and the operational costs are very high. This is also a hacker's paradise. Why? Because the hackers can access the data at the DMZ, and they have access to the internal network using the open ports in the firewall. So we all agree that the situation of the DMZs today, the role of the DMZ network has been significantly changed. From a simple network that only allows access to external static web pages, we now find huge DMZ networks with a lot of information in there, and this was not the initial purpose of the DMZ. And this is what we want to change with RSAccess. So imagine you could eliminate sensitive data from the DMZ to close incoming firewall ports to simplify your network architecture while gaining immediate cost savings and enhancing your efficiency. So let me introduce you to RSAccess. RSAccess is composed of two nodes, an external node which is deployed at the DMZ, and an internal node which is deployed in the LAN, in the internal network. Any incoming request to the applications arrive to the external RSAccess, and then it's immediately pulled by the internal RSAccess into the internal network. Then the request is sent to this specific application for response, and the reply is sent back using the internal RSAccess to the external RSAccess and then back to the user. The firewall only needs to open ports from the internal network to the external network. So from the internal RSAccess to the external RSAccess. This is the only port that is open in the firewall. So there is no incoming port from the DMZ to the internal network. All the communication between the internal RSAccess and the external RSAccess is done over outgoing firewall ports and no incoming firewall ports. To better explain how RSAccess works, let's have a look on a standard SharePoint deployment at the network. Usually what we find is a classic 3-tier deployment model where actually there is a SharePoint web front end that resides at the DMZ, SharePoint application servers, and the SharePoint database servers which reside at the internal network. Now, what are the problems with such a deployment? We have identified several issues. The first one, the security issue number one, is that there is a constant incoming hole in the firewall. Security issue number two, data and sensitive data is stored outside of the organization LAN on the SharePoint web front end. In addition, there is a great complexity. Data is duplicated and constantly synced between the internal network and the DMZ. And there is also a cost associated with such a deployment, as duplicated application licenses and hardware have to be maintained. So these are the security issues and the operational and CapEx that are involved with the standard deployment of application today. Now let's have a look how the same application deployment will look like with RSAccess. So we will deploy the internal RSAccess at the internal network close to the application servers. And the internal RSAccess will communicate with the application servers. Then at the DMZ, we can eliminate the SharePoint front-end server and to deploy the external RSAccess. Now, the internal RSAccess is constantly checking for new requests. So there is an outgoing port in the firewall from the internal RSAccess to the external RSAccess, which allows both devices to communicate. Now let's have a look how a user request flow looks like. A user request is sent to get some sensitive information from the SharePoint application. The request is captured by the external RSAccess, and then it's immediately pulled by the internal RSAccess into the internal network. Then the internal RSAccess is sending the request to the application servers, and the reply is sent back from the application servers through the internal RSAccess to the external RSAccess and back to the user. So let's look back on the challenges that we've identified, and let's see how RSAccess helps us to overcome those challenges. So the first security issue that we've identified is that there is a constant incoming hole in the firewall. Now with RSAccess, when the communication is done only from the internal RSAccess to the external RSAccess, we don't have such a security issue. So this has been fixed. No incoming hole in the firewall. The second security issue was about the sensitive data that is stored outside the organization LAN. When we deploy it with RSAccess, we can eliminate the web front-end service from the DMZ. We can eliminate the databases from the DMZ, and we can also eliminate the Active Directory or any other application servers from the DMZ. Basically, all the sensitive information can now be stored in the internal network. So we also fixed this security issue. Then we reduce the complexity. Now data doesn't have to be duplicated and synced all the time between the internal network and the external network. So all the data resides in the internal network, which means that it doesn't require synchronization and duplication. And in terms of cost, We don't need to have any more duplicated application licenses and hardware, and we can eliminate a lot of the costs that are involved with deployment of applications at the DMZ. Now, a single RSAccess can support multiple applications. It's fairly easy to create an application and protocol profile at RSAccess, which allows you to achieve even a greater cost reduction by consolidating and eliminating multiple applications from the DMZ. Another popular use case of RSAccess is to secure classified networks. So sometimes large organizations, when they have multiple classified networks, such as DMZ1 and DMZ2, or just two classified networks within the internal network, it's easy to secure those networks with RSAccess. So on one of the networks, we'll put the internal RSAccess, on the other classified network, the external one, or the one at the DMZ. And basically, it allows us to have a secure communication between the internal classified network. Other use cases of RSAccess are remote users to internal networks that I mentioned, classified networks within the enterprise, a B2B, enterprise-to-enterprise communication, a parent company to a daughter company, acquiring company to acquired company, and we also see quite a popular use case where OEM system that's required to send information back to the headquarters are utilizing the RSAccess mode. Okay. Quite often we've been asked what's the difference between a reverse proxy and an RSAccess, and I would like in the next 3 slides to show you what are the big differences between the two solutions. So usually what we found today in DMZ networks, we find a reverse proxy. And the reason for that is because the reverse proxy publishes the internal application, but in order to access the internal application and to get information from the internal application, the reverse proxy needs an incoming port in the firewall. So when a hacker performs a port scan on the firewall, in the case of a reverse proxy, usually, quite easily, it will find all the open ports from the DMZ into the internal network. When the same operation is done by the hacker on RSAccess, there are no incoming holes in the firewall, therefore nothing can be open, nothing is scanned. Another use case, or another issue, is when hackers are trying to compromise the applications using malware. With the reverse proxy, they can achieve this by injecting malwares into the SharePoint application. When they will try to do the same operation on RSAccess to compromise the SharePoint, the malware will be blocked by the internal RSAccess, which runs and provides application layer protection to attacks and to viruses and malware. And the third difference is when a hacker will attempt to hack the reverse proxy itself, and from there to attack the LAN and to compromise the SharePoint application. So reverse proxies, and it doesn't matter which reverse proxy we're talking about, they all have vulnerabilities which allow hackers to take advantage of this and exploit it. When our hackers will attempt to hack the RSAccess and to attack the LAN, usually they will find that there is nothing to hack on the RSAccess. So the external RSAccess is a very thin client. There isn't any application there, and nothing can actually be hacked. So just to quickly summarize the differences between a reverse proxy and an RSAccess, we can see that the safety RSAccess protects from network layer attacks, layer 3 and layer 4 attacks, protects against application layer attacks, and it's resistant to hacking attempts. While a reverse proxy is actually vulnerable to network layer attacks, also to application layer attacks unless it's deployed with an application firewall, and hackers can exploit the reverse proxy itself and to from there take control of the reverse proxy and try to attack the network. RSAccess provide unmatched security, and when we're looking on the type of attacks that RSAccess can eliminate and detect and mitigate, we can see that there are layer 3 and layer 4 level attacks, such as IP spoofing, ping floods, TCP floods, port scanning, ICMP attacks. Any TCP-based attacks such as SYN floods and so on are also mitigated by the RSAccess. In terms of application level attacks, RSAccess provides RFC compliance checks both for HTTP and HTTPS. So any attack that will try to compromise the standards and the compliance of HTTP will be blocked. SQL injections, viruses, malwares can also be detected and mitigated by the application level security of RSAccess. And it's resistant to hacking attempts. The external RSAccess is impervious to hacking. Basically, there's nothing there to hack. So let's look again on the DMZ network that we started with, and let's talk a little bit on the future of DMZ. So today, we all agree that the DMZ networks are becoming very complicated, very large to manage, and very expensive. And they also expose the network to many security breaches. When RSAccess is deployed, the whole network looks different. So nothing is now resided at DMZ. The only thing that resides at the DMZ is the external RSAccess. Then hackers cannot access the internal network. Sensitive data is now protected because it only resides at the internal network. The DMZ architecture is greatly simplified, the operational costs are reduced, and you achieve compliance much quicker. So let's just summarize the RSAccess session with the benefits. So what are the benefits of RSAccess? Enhance security, close incoming firewall ports, eliminate sensitive data from the DMZ. You can achieve much quicker compliance because there is no data that is stored in the DMZ and there's no incoming firewall ports, which means that the scope of the compliance now is much smaller. And when the scope is smaller, you can achieve it quicker and in lower cost. You can also achieve immediate cost savings by eliminating duplicated application licenses and eliminate hardware costs of front-end servers, and to increase the operational efficiency by eliminating constant data synchronization from the internal network to the external network, reduce servers runtime, bandwidth, and errors, and it's a much simpler deployment with minimal management. So this is the introduction for the RSAccess session. Now I would like to take another 5 minutes of your time and to talk about the other solution that we have at Safety. I want to talk about the Safety Box. Safety Box is an enterprise-wide secure collaboration platform. What does it mean? Safety Box allows you to share and sync files and sensitive data with others. It's a highly integrated solution. It comes out of the box with 120 connectors to applications and tools in the enterprise. It supports multiple storage and protocols such as FTP, SFTP, SQL, MySQL, SharePoint, Oracle CRM, and so on. And it also has connectors to Amazon and to Azure Cloud. It's a very secure solution because files are encrypted and require a password to access it. Files are not stored in the DMZ, and this is thanks to the RSAccess solution. So the Safety Box resides only in the internal network, while the RSAccess is deployed at the DMZ and in the internal network, so no sensitive data is exposed to the DMZ. And you can integrate Safety Box with any security tool, which allows you to have a data scanning both on incoming traffic to the Safety Box and outgoing traffic from the Safety Box or from your organization to any other location. It's a very collaborative solution. You can sync and share files from any device on any location. It can be on-premise, It can be personal cloud storage such as Dropbox or Google Drive. It can be a B2B solution. And you can invite others to view, to edit, to upload, and to download files using the safety box. And you can run on top of this platform, you can run multiple solutions. For example, secure email that doesn't require PGP, secure MFT, managed file transfer. You can have a distribution of classified reports from an application to external users by email, and more and more and more. So there's multiple use cases which I will cover in a minute. So let's quickly look on this scenario here when we have the safety box at the center and we have data sources. Data sources can be either an email or data that resides in some folder, some database, or at any storage, or any application within the enterprise. As I've mentioned, we have connectors to 120 applications. Once the data is being checked into the safety box, and this can be done in multiple ways, safety box will run a verification process. It will perform authentication with the Active Directory or LDAP or any other authentication service that you have at the organization. It will scan the data. So incoming traffic will go through an antivirus, file filter, etc. Any outgoing traffic will go through a DLP. Once safety box verifies that the specific user is allowed to send the data which is trying to send out, it will go through a secure process which will encrypt the data, generate one-time password, and then the data is ready to be sent to its destination. Now the destination, again, it can be an email, it can be any storage outside of the organization, including Dropbox, SkyDrive, Google Drive, or many other cloud-based services, or it can be another application, whether in our organization or in any other organization outside. Let's have a look on a few use cases just to make sure that it's clear. First of all, here is a use case of uploading sensitive data to Dropbox. So let's say that you have a design file, that you're a large manufacturer and you want to share your latest design with a supplier. And the supplier has a Dropbox account and a Dropbox folder, and you want to share this file using Dropbox. What you can easily do is you can integrate the safety box into authentication service, DLP, and then to the SharePoint folder. So the data source can be placed in a folder within the enterprise. From there, it will be taken into the safety box automatically. We'll run through authentication and DLP to make sure that this user is allowed to send such a sensitive information to Dropbox. It will be encrypted, and then the data will move to the SharePoint, to the Dropbox folder in the cloud. Then the partner, which you're sharing the Dropbox folder with, will come, and using the password will have access to the sensitive data. Another use case, another example, is distribution of classified reports. So think about bank statements or insurance applications or insurance statements that need to be shared with lots of external users. The data source in this case is a legacy insurance application. The data is then checked in automatically into the safety box, which will run a verification process, will sign PDF the document, will look at the CRM system for the email address and the mobile phone number of the user that is supposed to get the report. Then it will send over email to the external user or to the insurance agent, and the file will reside at the safety box until the external user will come and will take the file from the safety box. In this use case, where there is a bank which is utilizing the safety box to deposit checks from a mobile application. So in this case, the data source is outside of the organization. It's actually a mobile bank application. But once the check is being scanned and processed through the mobile bank application, it will arrive to the safety box, which will run authentication, antiviruses, file true type, make sure that there is no malware or any other zero-day attack within the image of the check. And then the checkout process, it will be sent into an application in the bank where a banker can process the check. And the last use case is the secure email. Again, user can generate emails. They can encrypt the emails utilizing safety box. Then the file will go to safety box. Will run through authentication, a DLP, and encryption. And an email with a secure link will be sent to the destination. And then the external user will come and will come to the safety box to receive the email. So it's all encrypted and secure. So this is what I wanted to cover with you today. If you have any questions, can you please type them at the questions box, and I will try to answer them. Okay, the first question that we have here is about the hardware requirements of the RSAccess. Well, the hardware requirements they're pretty much dependent on the throughput that runs through the RSAccess, the amount of concurrent connections, and the performance that you need. RSAccess is coming with an appliances from safety, which can allow you to have an easy deployment and easy integration into your network. So if you mind to send me an email, and I will be happy to share with you the hardware requirements per your needs. Okay, there is another question: if we have a cost analysis for RSAccess, if you have X numbers of servers in the DMZ, how quickly RSAccess can pay for itself by eliminating hardware and software costs for the DMZ. Okay, so that's an excellent question. We do have some ROI calculations that we can do, but it's very much dependent on the deployment of the application at the organization and the way that the organization is paying for the applications. So different applications have different pricing models for different organizations. But we will be happy to run this cost-saving exercise with you. So please feel free to send me an email, and I will be happy to share with you how RSAccess can achieve immediate return on investment and to save costs. Okay, another question that we have. How is RSAccess superior to a web application firewall? Okay, so that's an excellent question. RSAccess is not a replacement for a web application firewall. The role of web application firewall is to protect the web applications from threats that are coming from the external world. RSAccess has a different role. RSAccess role is to eliminate the sensitive data from the DMZ, to close the incoming port, and it's another layer of security that you will deploy at the DMZ and in the internal network. So it's not a replacement for an application, for web application firewall. Okay, any other questions? Okay, we have questions about achieving compliance. So is it possible to achieve compliance quicker with RSAccess? So the answer is absolutely yes. When there is no data stored at the DMZ and there is no incoming firewall ports, the scope of the compliance is much smaller. So if you're thinking about, for example, a HIPAA compliance, during the HIPAA compliance test, data that is stored at the DMZ will try to be penetrated. They will run penetration tests and so on. But if you don't have this data at the DMZ, you're reducing the scope of the compliance, and you can achieve compliance quicker and in a lower cost. All right, so we don't have any further questions. If you have any further questions, feel free to to send me an email with the questions. I would like to thank you very much for taking the time to listen to our webinar today, and thank you very much for attending.